Welcome to today's petite little video, biochemistry for why the frick did my neighbors just decide to mow their lawn? Okay, we're doing this anyways. Welcome to today's episode in biochemistry for biohackers. Today's episode is everything you need to know about ATP and a teensy-weensy little bit about sugar and fatty acid metabolism. Part 2 is going to be all about creatine, so make sure you pay extra good attention to this video so that the creatine one makes so much more sense. Okay, I need to calm down before actually start this video, because if I don't calm down and I'm all energy, then this video is going to be absolute rubbish. Okay, part 1. What actually is ATP? This is literally ATP. It is adenosine triphosphate. So if you're familiar with DNA chemistry, you already know what nucleosides are. If you're brand new to DNA chemistry or biology, molecular biology, biochemistry, adenosine is a nucleoside. So it is a nitrogenous base plus a ribose. This is adenine and this is ribose. This is a 5-carbon sugar. Adenine plus ribose is adenosine. And then adenosine triphosphate is the adenosine molecule with 3 phosphates attached. So altogether, this is ATP, adenosine triphosphate. This molecule can also exist as ADP, adenosine diphosphate, or AMP, adenosine monophosphate. ATP is cellular energy. This is what is directly powering metabolic reactions, protein synthesis, DNA repair, hormone neurotransmitter vesicle trafficking reactions. All these things happening inside your body, inside of your cell that need energy, are getting that energy from ATP. So how does ATP actually directly power these cellular mechanisms and reactions? It is because of this phosphate situation here. So see that? Here's what a phosphate molecule actually is. It's PO4 3-, so 1 phosphorus, 4 oxygens, and then 3 negative charges. When you start putting these phosphates together, you go phosphate, phosphate, phosphate. Having these negative charges so close together is very unstable. It creates a lot of charge repulsion, and it is very favorable for one of those phosphates to pop off. When that phosphate pops off, the molecule is now more stable and energy is released. So think of all these phosphates beside each other as a loaded spring. It takes a lot of energy to keep that spring compressed, and as soon as you pop off the phosphate, the spring goes wing, 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 and that P goes flying off and energy is released. This ATP molecule is hanging out in your cell. It's very unstable, and ATP hydrolysis, when that happens, this P pops off, energy is released, and that energy is coupled to non-spontaneous energy needing reactions. Muscle contraction, literally your heart beating or breathing. When you're breathing, your diaphragm is contracting. Those require ATP. DNA expression, DNA synthesis, DNA repair, protein synthesis, enzymatic reactions, those all need ATP to actually function. So this ATP molecule is showing up. You get ATP hydrolysis, this P pops off, energy is released, and that energy is coupled to the non-spontaneous reaction, and that energy pushes the reaction forwards. So ATP is cellular energy. Sugar and fatty acids represent stored energy. So sugar, fatty acids, proteins as well, these all have calories in them. They represent energy to your body. Sugar and proteins represent 4 calories per gram. Fat represents 9 calories per gram. And your body will metabolize these macronutrients to make ATPs. And the reason why sugars and fats represent stored energy is because of their highly reduced carbon and hydrogen bonds. So a sugar molecule is C6H12O2, and a fatty acid molecule is a bunch of carbons, a bunch of hydrogens, and a few oxygens. A fatty acid has a long hydrocarbon chain. That hydrocarbon chain is full of reduced carbon-hydrogen bonds, and each one of those reduced carbon-hydrogen bonds represents a large amount of stored energy that your cell can tap into, extract, and use that to make ATP, and then use that ATP to power exercise, working out, DNA synthesis, repair, all these energy needing reactions. Sugar, glucose, that's coming from food, and your body can have that glucose floating around in your blood as blood sugar, and cells can take in that glucose from your blood and begin metabolizing that and using that to make ATP. Or muscle cells, they can start taking that glucose from your blood and storing that as glycogen. Glycogen is how your body stores sugar for energy, and it's storing glycogen in your liver and in your muscle cells. Fat, obviously we all already know, if you eat too many calories, if you're eating too much food, you're gonna start storing more body fat, and that is literally because you are eating more calories than your body is burning. So you are taking in more energy than your body is burning. So your body's gonna start storing that energy, and the best way to store that energy is as fat inside of fat cells. So triglycerides, fatty acids, these are stored in adipocytes, and that is how your body is storing fat as energy. And because a fatty acid has such a long hydrocarbon chain, all these reduced hydrocarbon bonds, every single one of those reduced hydrocarbon bonds represents stored energy. As soon as your body starts saying, hey, we need more energy, now it's gonna start breaking down glycogen, the sugar stored in your muscles, or it's gonna start releasing fatty acids from your fat cells, and it's gonna start metabolizing those sugars and fatty acids inside your mitochondria, and it's gonna start making ATP. ATP has a half-life of about 5 to 15 seconds, and that literally just kind of goes to show how unstable or how highly reactive and how spontaneous its hydrolysis is. So because squeezing these phosphates so close together, having all these negative charges so close together, because that's creating so much charge repulsion, it's very energetically costly, very energetically unfavorable for ATP to actually exist as ATP triphosphate. Inside your cell, it's so speedily gonna hydrolyze and now exist as ADP. And when it makes that transition from ATP to ADP, energy is released. So ATP represents usable energy. ADP kind of represents spent energy. ADP is not really going to give your cells any energy, and once you have ADP, now you need to start engaging in more metabolic processes. Like you need to start burning more sugar and burning more fatty acids to start rephosphorylating ADP into ATP. So inside your cell, if ADP levels are increasing, that signals to your cell to increase glucose oxidation, sugar burning, and increase beta oxidation, fatty acid burning. The reason why you have high ADP and low ATP is because your body was literally burning more energy. ATP is energy. If you're using energy, you're using ATP, you're popping off the P, and now all these ATPs are transitioning into ADPs. So once you start working out a lot, you're running, or if your body is just burning through its energy supplies, ATP levels decrease, ADP levels increase. And another kind of signaling event that could be happening as well is if you're transitioning from ATP to AMP or ADP to AMP. So adenosine triphosphate to adenosine monophosphate with one phosphate molecule. AMP is a very metabolically, biologically relevant signaling molecule because just like the case of ADP, if AMP levels in your cells start increasing, that's... Whoa, sorry, I had a tickle in my throat. Pardon me. If AMP levels start increasing, that stimulates these metabolic pathways where we're breaking down more sugar, breaking down more fatty acids to get more energy available to your cells. So we're increasing metabolism such that we can make more ATP and we can begin powering these biologically super important reactions and mechanisms again. Whew. This video took me like 2 hours to film, so I really hope you enjoyed it. Let me know in the comments what was so totally awesome about this video. Whoa, what am I even saying? Let me know in the comments what you liked and what I can improve on so I can make these videos better for you. Also, by the way, if you want to get the complete set of notes, go to my website, nutritionbyelsa.com, and you can get all the notes on ATP, creatine, lactic acid cycle, glycolysis, tricarboxylic acid cycle, all the videos in the series Biochemistry for Biohackers. You can get the complete notes on my website, nutritionbyelsa.com. And also, I literally wrote a whole entire book about eating for brain health, skin health, and liver detox. And it comes with 23 charcuterie recipes. So go to my website, nutritionbyelsa.com, and get the book, The College Girl's Guide to a Better Brain, Glowing Skin, and Effortless Nutrition. And I hope you all have a rocking day. See you later, everybody. Bye-bye. Mwah.